Let's look at number one on the review. You've got two pentagons that we're told they are similar. So we need to find the scale factor. All you need to do is find a corresponding side for each pentagon that you know the lengths of. Okay? So, for example, AB and PQ, because of their names and the way they're written in the names of the similarity statement, those two sides are corresponding. So AB is here, PQ is here. And so right off the bat, we have a set of corresponding sides that we know the lengths of. Okay, so we want to find the scale factor of this one to this one. That means the red to the green. So the length of the red to the length of the green on those corresponding sides, when you reduce that, you end up with your scale factor. 15 to 21 is the same as 5 to 7. That's your scale factor. Okay? Scale factors can be written a bunch of different ways. Sometimes they're both integers like this, reduced. Sometimes it's a 1 to something, and sometimes it's a something to 1. But this is probably the simplest way, just to reduce that like you would reduce a fraction. So then we need to find the perimeter. So we're missing some pieces on the first one and the second one. But we have a hint. Those three sides are all congruent. That little dash means they are congruent. So if ED is 10, so are these. So we have 1, 2, 3, 4. We have all 5 sides of A, B, C, D, E. Or A, B, C, D, E. So we add them up, you get 20, 30, 40, 50, 65. So the perimeter of the first one is 65. We go to the second one. Now remember, we're going to need our scale factor here. It's a scale factor of 5 to 7. So let's look at CD. CD and RS are corresponding. So if we have a scale factor of 5 to 7, and I know there's not much room on this paper, so you may need a piece of notebook paper to actually work these out on. If it's a scale factor of 5 to 7, this one 5, this one 7, we know that that side on the first pentagon is 20. We're missing SR. Let's call it X. So we have something to put there. So 5 is to 7 as 20 is to something. Okay? So we can cross multiply. If you can't really do that in your head, you can cross multiply here. You get 140 equal to 5x. You divide both sides by 5. You get, what, 14? No. 28. Yeah. So x equal to 28. That'll be this. We need the other 3. So again, we kind of start with that 5 to 7 ratio again. 5 is to 7, but let's look at ED and compare it with RQ. Because ED, which would be RQ, ED and ST would be the same. Okay? So we'll call that, since we already used X, we'll use Y. So ED and ST, they're all congruent, so they should all be in the same ratio, but 10 to what? This should be a little bit easier to do in your head. If you had to double that to get that, you're probably going to have to double the bottom to get the same thing. Because all you want is a fraction that's equivalent to 5/7 with a numerator of 10. We called it Y. So 5y equals 70 divided by 5, 14. So if this is 14, then so are these. So we add all of those up. Now, if you already knew that the scale factor of the sides is going to be the same as the scale factor on the perimeters, we could have shortened this up a lot. Okay, but sometimes we don't know that unless we're exploring like this. So if the perimeter is 65, now, did y'all add those up yet? What do we get? 91? If we didn't know what the perimeter of the big one was, but we knew the scale factor was 5 to 7, we could have also, call it Z, done a cross multiply with the scale factor, because we would still be in a 5 to 7 ratio. If the sides are in a 5 to 7 ratio, then the perimeter is going to be in a 5 to 7 ratio. And we could have found Z, 7 times 65 equals 5Z. We could have found Z by doing this, 7 times 65 divided by 5, and that would have kept us from needing to find these, if all we needed to know was perimeter. But either way, if you get 91, I don't care if you use it, if you go through and find all the sides, or if you set up the scale factor for the perimeter. I'm good either way. The ratio of the measures of the sides of a triangle is 679. The perimeter is 77. So we don't know the lengths of them, but we know they are in a certain ratio to each other. So in a situation where, like this, we are going to have a scale factor. We're going to call it K. So 6 times that scale factor plus 7 times that scale factor plus 9 times that scale factor should equal 77, because 6, 7, and 9 doesn't equal 77. Does it? Like 22. So it's not going to be 6, 7, and 9, but it maybe it's twice that. It may be like 12 and 14 and 18, or maybe it's 3 times all of those. I don't know. But that's what I'm looking for, is this scale factor. What can I multiply? What one number can I multiply 6, 7, and 9 by and get sides that add up to 77? So we just go through like an algebra problem. We add that all up. We get 22K equal to 77. Divide by 22. And both of those are divisible by 11. We don't get anything real nice. And if you put it in the calculator, it comes out a little bit easier, 3.5. It's not horrible. We didn't have to round or anything. But if we want to find the measure of each side, then 3.5 is our scale factor. So that means the smallest side is not a length of 6. It's a 6 times 3.5. And a 7 times 3.5. And a 9 times 3.5. That'll give us the lengths of all 3 of those sides. So 18, that should be like 21, 21 and 24 and a half. And then 27, 31 and a half. Check my multiplication. But when you add these 3 numbers up, you get 0, 31, 1, 2, 6, 7, 2, 4, 5, 6, 7. So a 21, 24 and a half, 31 and a half, those 3 sides do add up to 77. So I have a perimeter of 77. Those 3 numbers are also in a ratio of 6 to 7 to 9 with a scale factor of 3.5. Okay? So basically you start out and just create an equation and use algebra to solve that for that K value, that constant that we're looking for, that scale factor we're looking for. And you use that to plug back in if it asks for each side. So this is our actual answer. These are the three sides of the triangle. Find the measure of each side of the triangle. Okay? These triangles are similar. We need to find the value of x. So let's look for some corresponding sides. Okay? So AB corresponds with, that's the shortest side, x minus 3. Okay? And then AC is going to correspond with FD. Oh, do that in here. And we don't really have any measurements for this longest side, so it's not really important that we even worry about it. With the other two, we can set up a proportion. So AB is 6, that is a 6, right? Corresponds to x minus 3. And then on the other one, we have a 12 on the big one, corresponds to an x plus 1 on the small one. We have our proportion, cross multiply. You got to remember, when you cross multiply with binomials, you make sure you put those in parentheses. So 12 times x minus 3 equals 6 times x plus 1. Put those binomials in parentheses. You can distribute correctly. 12x minus 36 equals 6x plus 6. I'm going to subtract 6x from both sides, and at the same time I'm going to add 36 to both sides. That will cancel that and that. And so my next step, bring it over here, will be 6x equal to 42. 12x minus 6x is 6x. 6 plus 36 is 42, and everything else cancels. Equal sign stays in the same place. So divide by 6, and 6 times 7 is 42. So my x value should be 7, and that does answer what they ask. Sometimes they'll ask for the lengths of the sides of the smaller triangle, and you got to plug that x value back in. But not today. You just ask for the value of x. Alright. Real similar to the one we did before where we had that scale factor for the sides. This time we're talking about the angles. So it told us a perimeter last time, and so we had something to set it equal to. But on this one, we're not told the total. They're expecting you to know what the total sum of all of the angles inside a triangle would be. What is it? 180. So we have a scale factor we don't know. We're going to call it K again. 4K plus 5K plus 6K. We need things in a ratio of 4 to 5 to 6 that add up to 180. We set it up like an equation, then you use our algebra to find K. And then we plug it back in to find the measure of each angle. So we've got 9K plus 6K would be a 15K equal to 180. What does that come out to? 12? So if K is 12, then 4 times 12 will give me one of the angles. 5 times 12 will give me the other angle. And 6 times 12 will give me the third and largest angle. So that would be a 48, a 60, and a 72. So check your, I know that these are going to be in a 4, 5, 6 ratio because I multiplied by 12. I multiplied 4 by 12, 5 by 12, and 6 by 12. I just need to double check that they add up to 180. 8 and 2 is 10, carry the 1. 4 and 6 is 10, plus 1 is 11, plus 7, 18. I got that 0, there we go. It checks out. So the sum is 180. I'm good. Those three angles will make a triangle. 48, 60, 72 are possible angles for a triangle. They are also in a ratio of 4 to 5 to 6. Just like the question needed me to find. Okay? This is your answer. Ask for the angles. Okay. So, on this one you may have to turn your paper around every so often, but if you have a median like this, okay, and we have another median on this triangle, then the medians will have the same scale factor as the sides. So the sides, these two triangles are going to be similar. We've got two angles the same. This angle is the same as that angle. This angle is the same as that angle. So all I need is angle and angle to make sure that the triangles are similar. So I'm good there. So now the scale factor between these two similar triangles will be 39 to 26. Those are corresponding sides on the two. 39 to 26. That reduces, both of these are divisible by 13. It reduces down to a 3 to 2. So these triangles have a 3 to 2 ratio. That means the medians will also have a 3 to 2 ratio. So 3 is to 2 as 25 is to x. I see what I did. The medians are just like the sides as far as scale factors are concerned. Cross multiply. 3x equal to 50. Don't panic. Just because 50 is not evenly divisible by 3, it's okay. We get a decimal, it's okay. Or we can leave it as a fraction. I don't care. Either way. I don't mind leaving it just like that. If 50 over 3 can't be reduced, I don't mind leaving it just like that. Okay, here we have an altitude. UA is an altitude. The triangle is actually only STU and XZY. Those are the two similar triangles for XYZ. But UA is an altitude. That means it drops down from U to the line perpendicular to the opposite side. ZB drops down to the line that's perpendicular, or that corresponds with XY. A line that goes through XY, Z falls right straight down onto that line. So the altitudes, though, well, we got to label some stuff. They didn't label the picture for us, so we got to come back in and label. UT 8.5. I need to make this work. UT 8.5. UA 6. CB 11.4. We need to find ZY. This is the one we want. We have those corresponding links on the smaller triangle. Those triangles are proportional. they're similar, so they have a constant or a scale factor. So using the scale factor on the altitudes, it will be the same scale factor as these corresponding sides. So 6 is to 11.4, those are the altitude lengths, as, and I'm not going to try to reduce it, it won't reduce to decimals, we're just going to go straight into the cross multiplying, let's call it X. So you're going to get some decimals. Just go through the same process. Just going to have to use your calculator. 8.5 times 11.4. Who's got that? 96.9. Okay? 96.9. We divide by 6 on both sides. 16.15. And is that what it wanted? No. It wanted ZY. Oh, yes, that is what we wanted. ZY was X. We call it X. All right. Number 9. Bridge construction workers placing rivets in a new bridge. This is the easiest problem. It just has a lot of words in it, so I don't like to read, so you may have skipped it. Uses 42 rivets for the first 2 feet. There's 2,200 total feet. How many rivets? About how many rivets would he need? 42 for every 2 feet. How many in 2,200 feet? Those will be proportional. Call it X if you need a variable. 2X equal to 42 times 2,200. Divide by 2. Put it in piece by piece or all at one time. X would be 42 times 2,200 divided by 2. It should come out, typing in the calculator right, to 105 rivets. Everybody agree? Anybody agree? Anybody do it? Okay, good. That was really small. Okay, not even a problem. Just can you cross multiply? 5x, and it's just a 1 times 1.12, which doesn't do anything. Divided by 5, 1.12 divided by 5 is x. 0.224. Identify the similar triangles and find each measure. Okay. So the key here is we have parallel lines, right? And we got these 2 transversals. And on transversals of parallel lines, if you pretend that these are longer, then alternate interior angles are going to be congruent. So let's extend out red. Let's extend out green. make it easier to see. Interior, interior. Those are alternate interior angles. Those two angles will be congruent. Interior, interior. Same transversal, opposite sides. Those will also be congruent. So that proves that these two triangles are going to be similar, not congruent, similar by angle, angle. Okay, two angles of one, same as two angles of the other, forces the triangles to be similar. So they have a scale factor, they have a ratio. The EF side, this little piece down here, and the IH side, those are the corresponding pieces. So that means this little triangle is going to be smaller than that one. These triangles are in a 3-to-4 ratio. This side EG is actually going to correspond to HG. These double lines, see how they're in opposite corners? This one's at the top, this one's down here at the bottom, but this green line should touch them both. The corresponding pieces should touch the same congruent angles. So that means that x plus 1, if 3 is to 4, should be the same as x plus 1 is to x plus 3. So if we cross multiply, and remember when you cross multiply on binomials, if you have trouble with remembering to distribute, then you need to put those binomials in parentheses. You get your 4x plus 4, you get your 3x plus 9, subtract 3x from both sides, subtract 4 from both sides. We get a 4x minus 3x, which is 1x. On the right, we get a 9 minus 4, which is 5. That did not answer what the question asked. What's the key to making it happen? So EG is going to be x plus 1. When x is 5, that makes that 6. HG is x plus 3. That means that one's going to be 8. Okay? Now, if it wanted us to really identify the similar triangles, like name-wise, then triangle EFG would be similar to triangle. E is going to correspond with H. F is going to correspond with I. And G corresponds with itself. This one looks a little scary. It's really not that bad. These are congruent. Okay? And it is hard to read a little bit because we're not sure exactly what is it talking about. What is it referring to? It's talking about these lengths. Okay? This one has a length of 1/3 y plus 6. This one has a length of 2/3 y plus 3. They are congruent, which means they're equal. They only have y's. So we can just set those two expressions equal to each other in an equation and solve for y. And if these two are congruent, so are these. Not necessarily to those, but to each other. So that means those, if they're parallel, then that means they're the same distance apart all the time. Okay? And that means not only are these two the same distance apart all the time, but these two are the same distance apart as these two. So we have the same situation over here. The 3x minus 4 is equal to the 5 force x plus 3. So the algebra is a little bit harder. We got the fractions in this. Here's what I suggest, and what I find is the easiest thing to do when you're solving equations. Remember this for Algebra 2, okay, or whatever you've got coming up, PSATs, whatever. If you have a fraction in the equation, if you multiply, if you just have one, it's pretty easy. If you multiply everything by that denominator number, you get rid of the fraction completely, like this. So I have a 5 fourths. That 4 is giving me problems. But if I multiply everything, every term in that equation by 4, it goes away. But that means the 3x needs to become a 12x. The minus 4 needs to become a minus 16. But what happens to the 5 fourths x is it becomes just 5. Because 5 fourths times 4 makes the 4's cancel. And then the 3 times the 4 is 12. Now that looks a little bit easier for me to work with. The numbers are bigger, but I don't have any fractions. So if I subtract 5x from both sides, and I add 16 to both sides, it's going to get rid of those, it's going to get rid of those. I'm left with a 7x, bring down my equal sign, equal to a 28, and I can do that in my head. You can too. Didn't need a calculator. Same thing over here. The good thing about the second one is that, yeah, we have two fractions, but they have the same denominator. They have a 3 in the denominator. Okay? So we can multiply everything, each term by 3, it'll get rid of those fractions. 2/3 times 3, the 3 is going to cancel. Everything's going to get multiplied by 3. 2/3 times 3 is just 2, so that's a y, not an x. Plus 3 times 3 is 9. 1/3 times 3 is just 1 y, and 3 times 6 is 18. Now it looks a lot nicer. In fact, now I can, one step, collect my like terms on the appropriate sides and be done. When I minus y from both sides, subtract 9 from both sides, that'll go away, that'll go away. 2y minus y is just y. I don't have to divide by its coefficient in that last step anymore. If you have a fraction, that's one way to get rid of it. Multiply everything by that. Actually, it's the least common multiple of the denominators. There's different denominators, but these were the same, so that made it easy. Determine whether each pair of figures is similar. If so, write the similarity statement and the scale factor. So the angles are good. Okay? Based on the angles, these two would be similar. Okay? And K, if we started with K, and we can put like, I don't know how the shape of the figure, we'll just put it with letters. K, J, M, L. We'll go with that. K, J, M, L. Should be similar to K and R. Both have the two-line congruence. K and R. So since K came first, R needs to come first in this guy's name. J had the one-line congruence. So Q over here has the one-line congruence. M has 4 lines. P has 4 lines. L has 3 lines. S has 3 lines. So based on the angles, those are the names that should work. But we need to check all of the sides to make sure that these numbers are even possible. So we start with the shortest side, 15 and 12. So 15 over 12 should be the same as 20 to 15, should also be the same as, no, not 20 to 15, I'm on the opposite side. 20 to 9, sorry. Is that right? I gotta back up. All right. I've got to turn this guy in my head. I gotta start over here. Hold on. So I gotta turn this guy in my head. So this MJ is the same as that. ML is the same as that. LK is the same as SR, and KJ is the same as RQ. So we need to put the colors in the same ratio. 24, 14.4. That needs to be the same as, let's go to green, 15 to 9. Let's go to blue, 20 to 12, and finish up with red, 25 to 15. So if all of these, when you divide these down, if you get the same decimal every single time, that means everything is in the same ratio. That means everything has the same scale factor, and you're good. But if even one of those is off, then these numbers aren't even possible. Okay? But they all have to come out to the same exact thing. Do they? Which one's off? What is 24 divided by 14.4? That's right. 6, 6 repeating. All of them become that. Yeah. Better check. But yeah, they do. I'm pretty sure. Yep. So, you're farming. Your ratio, you're raising goats and sheep. You want to keep a 4 to 7 ratio between your goats and sheep. Right now you got 28 sheep. How many goats should you have? How would you figure that out?
7 times 4 is 28, 7 times 4 is 60.
How would we set that up if we couldn't follow what you were doing?
Divide the 7
Okay. Like that. So if that needs to be sheep of 28, 28 would need to go down there.
So then
You multiply by 4, you should get a 16. All right.
Good morning, hi. Morning Tybee High School, little Migos for our soccer boys because they got a big game tonight at Dripping Springs against Dripping Springs. What time, Jason? At 7 p.m., not a.m., but p.m. So, guaranteed win tonight. Jason's calling it, and I like the confidence because he's coming for Drip along with 10 people coming on the field for Drip. Seniors need programs in the area of nursing. Any student that is interested can pick up an application form from the one and only Miss Pinch and the one and only Miss Pepeska. Applications are also available in the counseling office. Next, we have Kirkland.
Join us April 8th for the April FFA meeting in E115. That's Ms. Harris's room. We will have dinner and vote for 2019-2020 officers. It's very important that all FFA members attend. Golden.
All senior boys. I repeat, all senior boys.
Permits are only $10, so that's like two $5 bills or just one $10 bill. And you must provide a valid driver's license and proof of insurance listing your name on it as well. So you can get